Okay, so we're simplifying radicals and complex numbers. Where's my highlighter? There it is. Okay, so it says square root symbol is also called your radical. So when it says simplifying radicals, that's what we mean. Okay, we're just simplifying square roots. Eventually we'll get to cube roots, but for now we're just doing square roots. They're over there in the turn-in tray. Okay, you're fine. So what we need to know about this is we need to understand what a square root does. So if I ask you what's the square root of 16, what's your answer? 4. And we know it's 4, but why is it 4 is what we're going to kind of talk about. Well, it's 4 because we know that 4 times 4 is 16, right? Which is the same thing as saying 4 squared, correct? Well, aren't square roots and squares inverses? And that means they cancel each other, just like plus and minus cancel each other. So the square root cancels the squared, and it equals just 4. Yes? So knowing that, we're going to take that into simplifying radicals when they're not whole numbers. Okay, because the square root of 80 is not a perfect square. 81 is, but not 80. So we're going to talk about prime numbers first, because we're going to build factor trees. I was including prime and factor in one word. Okay, I know that 1 is a prime number. Do y'all know what prime means? Like, what does it mean to be a prime number?
Like, 3, 1.
Yes, but why? Why are those prime? Because they can only be divided. Their only factors are 1 in itself. Does that make sense? Like 3. The only thing that can multiply to give you 3 is 1 and 3, right?
So odd numbers.
No. 2 is prime. Because the only thing that multiplies to give you 2 is 1 and 2. However, is 4 prime? No, because 1 times 4 does give you 4, but doesn't 2 times 2 also? You see what I'm saying? So 2 is prime. 3 is prime. The next prime number is 5. Then 7. Then 11, 13, 17, and it keeps going. They get far and fewer between because the bigger the number, the more likely they are to not be prime. Okay, but those are like the most common prime numbers that you're going to see us use today. Okay, mainly the first like 4. But just so you understand. So when we build our factor tree, which we're about to do, these are the numbers you want at the end of your branches. So let's get started on 80. So we have number 1, we have the square root of 80. And if you type that in your calculator, square root of 80, it does not equal a pretty number. So to simplify it, we can't just write that. So what we're going to do is we're going to break it down. And this is how I organize these. I'm a crazy person. Yes, but I'm always going to start with my smallest prime number other than 1. I'm not going to use 1 because 1 doesn't change anything and I'll be there forever. Okay, 2. Does 2 go into 80?
Yes.
Yes, so I'm going to start with 2. How many times does 2 go into 80? 40 times. Now 2 is prime, so that side's done. But 40 is not. So I always put my prime number on the left so it keeps them in line. Okay, you don't obviously have to do that, but it will make your life easier. 2 still goes into 40, 20 times. 2 goes into 20, 10 times. 2 goes into 10, 5 times. And 5 is prime, so we're done. Is everybody okay with that?
Yeah.
Now, one thing I've seen that a couple people have gotten confused on, we are no longer using the 40, the 20, the 10. Why?
Because they could be simplified?
Well, because we broke them apart, didn't we?
Yeah.
We broke that down. If we broke it down, you're not looking at those numbers anymore. We are only looking at the numbers at the end of the branches that I've underlined. Does that make sense? So we want to find something that doubles, because then we can cancel it and take it out, right? So we have this 2. We also have this 2. Now, does the 5 have a pair? No, so that one does not. So the reason we get to take out just a 2, now I'm only going to take out, because of this circle, I'm only taking out a 2, not 4, because this is the same thing as 2 squared. All of these numbers are still technically under my radical. Doesn't the square root cancel the squared?
Yes.
So that's why when I circle a pair, I only take one of them out, not both. Does that make sense? Because 2 and 2, this is 2 times 2 times 2 times 5. If I multiply all those numbers, I'm going to get 80. These are all the prime numbers that multiply to give me 80. So if I want to cancel the house as many times as I can, Well, this is 2 twice. Isn't that just 2 squared?
Yeah.
So I cancel the radical, and I get to take a 2 out. Well, this is also 2 squared. So if I square root that, I get to take another 2 out. And what did I have left over that I did not get to cancel? The 5. Well, what's 2 times 2?
4.
So 4 square root of 5 is my answer. Now, can we check our work?
Wait, so you put the 5 in the radical?
What didn't have a pair stays inside. Because we couldn't find a pair to cancel it to take it out. Does that make sense?
Yeah.
So if you look, if I type 4 square root 5, is it equal?
Yes.
Yes, then we did it correctly.
Okay.
However, we have to make sure that the inside still can't be broken down. I did have some people simplify them, but not all the way. So you can simplify it, but not all the way. Okay, but make sure it's the inside is, like 5 is prime, so we know for sure this couldn't go any further. Does that make sense?
Yeah.
Okay. Yeah, don't overthink this. It's not as bad as it could be. Let's look at number 2. So again, I always start with my smallest prime number. It's even. Does 2 go into 288?
Probably.
Yes, it's an even number. How many times? 144. If you don't know, could you just divide?
Oh, yeah.
Yeah. Now, is 144 a perfect square?
Yes.
Yes, and if you notice that, can you be done?
Yes.
Yes, because what times what gives you 144?
12.
12 and 12. Is that match? Is that match? Does that match? Let's use proper English here. Yes. Okay, so that's the only time you don't have to go all the way down to all the primes. If you can make it match, you can stop. Yes?
Yes.
So we made it match. However, did we still have something left over?
Yes.
So what gets to come out?
12.
12. And what has to stay inside? 2.
So there's nothing. So if they match, right, and there's nothing else on the outside, it's just that number.
Yes.
Okay.
Yeah, if there's no other leftovers that don't have a pair, then that means it's a perfect square. So that worked. They match. Yes?
Yes.
Okay. So let's look at number 3. What's different about number 3?
It's a fraction.
It's a fraction. Don't let the fraction scare you. The nice thing is there's the rules with radicals, and we can rewrite this as we can separate the numerator and the denominator.
To make like 2 separate fraction trees.
Yeah. However, 25, what do we know about 25?
25, 5 is 5.
It's a perfect square because 5 and 5. See how they both match and there's nothing left over?
Yeah.
That means my denominator is just 5. And there's no more house because there was nothing left over. Yes?
Yes.
Okay, however, 8 is not a perfect square.
No.
So we have to break it down. 2 goes into 8 how many times?
4.
2 goes into 4 2 times. So we have a pair of 2's that gets to come out. And we have a 2 left over that goes inside.
So that would be our answer?
Yes. Now, does 2 over 5 simplify?
No.
No. If it was 2 over 4, you would have to simplify it. Okay, because 2 over 4 would simplify. Now, you'll never simplify your inside radical, because this is how you simplify radicals. You can only simplify like your coefficient, your number in front. Okay, but that doesn't simplify, so we're good. Huh? I have no idea.
Oh, but can you,
Kyle writes on the board.
what do you
Here you
mean
go.
by like? What do you mean by like simplify?
Like if, so this is not what it equaled, but say we had something like 2 square root of 3 over 6. Doesn't 2 over 6 simplify? Okay, 2 goes into 2 how many times?
2 goes
Once. And 2 goes into 6 how many times? 3.
3.
So that would be your answer. You would have to simplify
Oh,
it.
so
Do you see what I'm
this is
saying?
divide.
Yeah.
Okay.
But this one didn't simplify, so we're good. Okay, number 4 has what?
Negative.
But where is that negative?
Outside.
Is that okay?
Yes.
Yes. Okay, so what I want you to realize is when there's no symbol, we have no symbol in the middle. What does it mean to have no symbol? Addition, subtraction, multiplication, or division?
I'll say.
Multiplication. Addition, subtraction, multiplication, or division. It's multiplication. So we know that our final answer is going to be negative 5 times something. Yes?
Okay.
So let's break down our 32 and figure out what we can break down. Well, 2 goes into 32 how many times?
16.
What do we know about 16?
It's a perfect square.
With?
4 and 4.
So remember, we don't have to go all the way to prime if we can make it match. So I'm going to take out what? 4, and what am I going to leave inside? 2. Now, we can simplify this because with multiplication and division, remember, they don't have to be like terms. So what's negative 5 times 4?
20.
Negative 20.
Negative 20.
Square root of 2, there is your answer.
So you multiply what's on the outside.
Yep.
But either way, if you didn't multiply, would you get this? I mean, simplify, would you get the same answer? Or no?
What do you mean?
Like if you just left it as like what it was.
Like if you went to 2 and 8, and then 2 and 4, and then 2 and 2?
No, like the 5 times 4.
No, you have to simplify it.
Oh, okay.
So if we did negative 5 square root of 32, and then we did negative 20 square root of 2, so we get the same thing. So you can always check your work if you're unsure with what you did. So look at number 5. What's different about number 5?
It's negative and it's a perfect square.
It's negative where?
Oh.
On the inside. So if you type this, because you said it's a perfect square, so I should be able to do it in my calculator, right?
Mm-hmm.
If I type this in my calculator, what does it tell me?
Not a real answer.
So we have a problem. Okay, so this is where complex numbers comes into play. But I want to show you why. So we're going to talk a quick minute about Algebra 2. I want to remind you that when you graph a quadratic graph, which is y equals x squared, it looks like this, right? This is your parent function. Everybody remember that? Do y'all remember doing inverses?
Yeah.
Okay, inverses, I don't know if you remember, but quadratic versus square root was the only inverse that didn't look exactly the same whenever you flipped it. Because when you graph a square root, it looks like this. So the other half disappeared, yes? And it's because you can't take the square root of a negative. So that is where your imaginary numbers are. Okay, those are your imaginary numbers. Because if you did the square root or the inverse of any of your other graphs, the inverse looked exactly the same except sideways. It flipped over the y equals x. This is the only one that when you flipped it, only half of it stayed, the other half disappeared. So that disappearing piece is your imaginary. Okay? So knowing that, anytime that we have a negative on the inside, this is what you're going to do. You are going to make it positive and put an I in front for imaginary. Yes. Now, what's the square root of 81?
9.
9, because 9 times 9 is 81. That matches. I have no leftovers, so it's just 9i. Now, proper is to put your I behind your coefficient or your letter, your constant here. Okay, is because, just like x. Now, a couple things. When multiplying 9i times 3, that's allowed, because remember, with multiplication and division, it's okay if they're not like terms, you can combine them. Yes? So what's 9 times 3?
27.
So this would be 27i. That's allowed because we multiplied. However, would you be able to do 9i plus 3?
No.
No, not like terms. Okay? Could you do 9i plus 3i?
Yes.
Yes, because they are like terms. What's 9 plus 3? 12. So you get 12i. It's the same concept with radicals. So you can have 9 radical 2 times 3. You can multiply that. You'll get 27 radical 2. However, you cannot do 9 radical 2 plus 3 because they are not like terms. But you can do 9 radical 2 plus 3 radical 2 because now they both have a radical 2. So you get 12 radical 2. So your radicals and your i's are almost just like, they follow all the same rules as a variable. Does that make sense? Okay. So knowing that, we're going to break down into these. Now, what I want you to realize when we look at these, does this look familiar at all from Algebra 2? Okay, and it's because when we get to this, which we will after this method, it's this formula.
Yeah.
Okay, the quadratic formula. So we're just going to kind of practice simplifying it because that's part of the reason we're talking about simplifying radicals and complex numbers. Okay, and then we'll get into it further, obviously, when we use that method to solve. So first things first, we need to break down this square root of negative 28. Well, first off, I'm going to make it positive, and I'm going to put an I so I don't forget.
So I doesn't go with the 10 because the 10 already has a plus.
Yeah, no, it goes with the radical, just right in front of that radical. So we have 28. What goes into 28?
28 is 74.
Always start with your smallest.
2.
2 and 14. I mean, you could do 7 and 4, but that's how my brain works. 2 and 7. So then my 2's are lined up. And then my leftover is 7. So I'm going to rewrite this as 10 plus or minus 2i root 7. Now, I'm going to separate my denominator. Why do you think I'm going to do that? Yeah, because doesn't 10 over 5 simplify? Now, what if I had a 7 on top? Would I need to separate? No, because nothing would simplify, so is it worth separating? No, but when something simplifies, you have to simplify it. So what's 10 divided by 5?
2.
So I get 2 plus or minus 2i square root of 7 over 5. Now this is the part that I feel like blew everybody's mind today. That plus and minus means that this is 2 different answers. Do y'all remember that?
No.
Okay, so because once it's can you add and subtract at the exact same time? No, that's why. But instead of writing this, would you want to write this simplified the whole time twice? No, that's why they put it together, to make your life easy. But now that it's as simple as it can get, without separating, we're going to separate. So we're going to have 2 plus 2i square root of 7 over 5 and 2 minus 2i square root of 7 over 5. Now those don't simplify any further, so I'm done. That's my answer. I did write that in fancy brackets strictly because it's a solution to the formula, even though we didn't start with the formula. No, I wouldn't take off on this page, but when we get to like the actual solving, I would. You see what I'm saying? Mm-hmm. Okay, number 7 hopefully will make a little more sense when it comes to that because it gives you a whole number. So what's the square root of 25? 5. Because 5 and 5, so it's pretty. There's no leftovers. So I have 9 plus or minus 5 over 4. However, I cannot add and subtract at the same time. So again, I'm going to separate. I have 9 plus 5 over 4 and 9 minus 5 over 4. From here, can I do it in my calculator?
Yes.
Yeah. Now you could do it by hand if you want to, but it's Friday and I don't want to. So alpha y equals enter, 9 plus 5 over 4. That gives me 7 over 2. And then I can hit second enter. You see how it types the whole thing for me again? And I can go to the plus and just highlight it and write a minus. And what I get 1.
So then our answers would be 7 over 2 and 1.
Yes. No, here's my trick question. Which one's smaller?
7 over 2.
No, it's 1. 7 over 2 is actually 3.5. I don't know why I put another comma. So, if you didn't write it in order, I'm not going to get mad, but just be careful. Okay, there is 2 more things I want to go over before I let y'all go. They're on your practice, though, so it's me helping you finish your practice. Look at number 18. Is everybody okay with writing this down? I can flip? Okay. Look at number 18. It's because this one has a little more to it. Well, first off, what do I need to do before I get started? Get the I. So I'm going to make it positive and put an I. So I know I have 4i times something. Well, let's break down 120. Does 2 go into 120?
Yes.
Yes. How many times?
100?
No. Always cut it in half. What's half of 120? 60. And then the nice thing is when you take out a 2, you're just cutting it in half. So 30, 2 and 15. Now, does 2 go into 15? No, that does not mean I'm done. What's your next prime number? 3. Does 3 go into 15? Yes. How many times? 5. So now, 1, 2, 3, all of my numbers are prime. Huh?
I said that's what I meant.
Oh, okay. I thought I heard something else. So I have a pair of 2, and then these 3 do not have a pair. So I'm going to take out a 2, and then those 3 have to go back inside. 2 times 3 times 5. Well, what's 4i times 2?
8i?
8i. And then what's 2 times 3?
6.
Times 5.
30.
There's your answer.
Okay.
So if you take out more than one thing that matches, is that okay? Yes, you'll multiply it together. If you leave more than one thing inside that didn't have a pair, is that okay?
Yeah.
Yes, you'll just multiply it together.
Okay.
Okay, one more. Look at number 21. Now, these are different from all of the other ones because they have a plus or a minus in the middle.
Yeah, broken plus.
What? No, because there's a radical in between, so it's different. But none of the other ones have plus or minus. 1 through 18 have no plus or minus. They have some negatives, but that's different. Okay, these have plus or minus. So first off, we're going to break down this. We're going to put an I. So we have 2 minus something. So let's break down 27. What goes into 27? 3 and 9. And then 9's a perfect square with 3 and 3. So I get to take out a 3. I have that I, and what was left over?
3.
A 3. Now, are these like terms?
No.
So can I go any further?
No.
So that's my answer. Don't freak out because it has a plus or minus. You do not have to combine them. Does that make sense?
Mm-hmm.
Okay, so don't combine them. Also, one more thing. Flip to the back. I know, you're so excited. So excited. You don't have to do number 20 and 30 yet. So don't cross them out. Just don't do now.
You get 2 days of practice?
Yeah, you'll have Monday. However, you have plenty of time to finish like at least the front. If